So today we're going to talk about another kind of division method, and this may be preferable to you than some of the ones we talked about before, long division and reverse box. The only thing about synthetic division that you need to be careful of is that it can really only be done in an easy format when you're dividing by a divisor that's just x minus 4, x plus 5, or something in that form, x minus k or x plus k. So what you'll be doing in these problems is essentially taking the coefficients of the problem you're working with, going through an algorithm, and when you're done with the algorithm, the answers on the bottom are going to end up giving you the coefficients of the answers. So let's just kind of walk through this process first, and then I can always come back and do another example. So I want to start with the fact that I'm dividing by x minus 4. So let me circle this. So x minus 4 is what I'm dividing by, but notice how I'm putting a positive 4 on the outside of that synthetic division box, okay? So you always want to take your divisor, x minus 4. If you want to think of it as something like, setting it equal to 0, and that's where you would get x equals 4. Eventually we'll learn how this is really a correlation of roots and zeros, but for now you could also think of it as the opposite sign of what you're dividing by. Okay, so now let's take a look at the coefficients of this problem, and once again, like I had mentioned in yesterday's lesson, you need to make sure that every single coefficient is represented from the highest power all the way down to the lowest. Watch out for placeholders. So notice I'm going from x cubed to x squared to x to regular number. Nothing is missing, so I don't need any zero placeholders. I'll make sure I point that out in another example. So now I'm going to take these coefficients, 2, -7, -8, 16, and you notice how they go along the top row of that synthetic division. Okay, so here's now the algorithm. I have my divisor number on the outside, I have my coefficients across the top. You're always going to begin by bringing down your first number. You're going to now multiply that by what's on the outside. 2 times 4 is 8, and put it in the next row. Okay, so now you're going to essentially repeat the same idea. I'm going to add down this column. Okay, so -7 plus 8 is 1. I take the number that I end up with, 1, and I multiply it by what's on the outside, and then once I multiply them, I bring that over, and it goes into the next row. Okay? So now I repeat. -8 plus 4 is -4. Multiply -4 times +4, and I end up with -16. And then I finish by adding down my row, and whatever. And then now I'll show you how you actually turn that into your final answers. Okay? So first things first, once you get to this final row, okay, this last number here, this is your remainder. So you can see in this particular problem, there is no remainder. This divides in evenly. The other numbers, the 2, the 1, and the -4, those are going to be coefficients of your solution. So now let's think about what we're doing in this problem. You're taking something like 2x cubed, dividing it by x minus 4, etc. So just for 1 second, let's just pretend we were dividing 2x cubed by x. What would be the result of that? That should start with something like 2x squared, right? Now, obviously, again, it's not that simple. I can't just divide the top and the bottom like I did if the bottom was a monomial, but my first term should start with something like 2x squared. Hence why this 2 as my first coefficient, that becomes a 2x squared. This second number, this +1, becomes a positive x, and this last number, -4, is just a regular -4, and that is now my final solution. So the fact that I started with 2x cubed as my very first term, I have to drop that power down by 1, and that's why x squared starts the first term in my quotient. And then similar to what we had before, if you had a remainder, you would add it on as a fraction on the end. Okay, so that's the general procedure. Now let's see it put into action a little further. Okay, so first things first, I'm going to start by taking that x plus 8, and I'm going to put the opposite sign of the x plus 8 on the outside of the synthetic division box. Then I'm going to take my coefficients, make sure that they're all represented, x cubed, x squared, x, regular number. I don't need any placeholders because nothing is missing. So I bring my coefficients, 1, -2, -78, and 16. Okay, so remember, you're going to repeat this algorithm until you have normal rows to be able to add down. So you're going to start. Bring down your first one. 1 brings down to be 1. 1 times -8 is -8, which I now put into that second row. Again, you're going to add down your column. -2 plus -8 is -10. Negative 10 now multiplies by negative 8 on the outside to become a positive 80 and gets put into the next row. Negative 78 plus 80 adds up to be positive 2. 2 multiplied by the negative 8 on the outside is negative 16. I add down my final column. 16 plus negative 16 is 0. Okay, so what do these numbers actually mean? Well, at 0 at the end, again, that's your remainder. So you can see in this case, this divides in fully even, so you don't have to worry about any fractional remainder. So now remember, I had started with x cubed as my very first term, which means my final answer actually has to begin with an x squared. Specifically, it's going to be a 1x squared. And then I basically just keep dropping my powers down by 1. So minus 10x, positive 2, and so therefore, x squared minus 10x plus 2 is your final answer in this particular case, because again, there's no remainder. So let's take a look at the next example. Again, so I would analyze this and I would say to myself, what kind of division method do I want to do? The fact that I'm dividing by something that's just x minus 2, that's what allows me to easily use synthetic division. Okay, and again, remember, you can still use reverse box if you want, you can still use long division, but you might find that synthetic is a little bit quicker. So you're going to start by taking the opposite sign of what's inside your divisor. So positive 2 goes on the outside. Check to make sure you don't need any placeholders. X cubed, x squared, x, regular number. Okay, we're good to go. Bring down your coefficients. 1, negative 8, 25, negative 50. Okay, so remember, it's add down your column, multiply by the outside, put it in the next column. So I bring down my 1. 1 times 2 is 2. Add down my column. Negative 8 plus 2 is negative 6. Negative 6 times 2 is negative 12. Put it in the next column. 25 minus 12 is 13. 13 times 2 is 26. So you're going to see these two do not add up to be 0 this time, so I'm not going to have a 0 remainder. Negative 50 plus 26 is negative 24. Okay. So once again, what you want to remember is that this is now my remainder, so that I'm going to need to have some sort of fraction added on to the end. The fact that I started with x cubed means my very first term starts with x squared, so I have a 1x squared, okay, negative 6x, positive 13, and then your remainder gets added as a fraction. So it will be either minus 24 over something or plus negative 24 over something, same difference. What's that something? It's whatever you divide it by, just like we did in yesterday's lesson. So that way it's, again, like a fractional leftover. Okay, and then you just box it off, and that's your final answer. Okay, so you can now see that there's a number of additional examples for you to practice, and you're welcome to go through and try different methods. Just as, in a general look, if you look through, if you notice any of these ones that you're dividing by just x minus 1 or x plus 1 or x plus 5, all of those you can do synthetic. However, when you get to a question like number 6, where you're dividing by 3x plus 7, unfortunately for that one, you'll have to go back either to long division or reverse box method, okay? So that you're not going to be able to do synthetic division with that one. So, let's just say for argument's sake, I'm going to change up number 2 for just a second. Let's say for argument's sake, number 2, instead of starting the way that it did, maybe it started with x to the 4th minus x squared plus 1, and I was dividing by x minus 1. I want to point out what happens with something like that and what you really have to be careful with. Hopefully you can kind of think of what I was kind of pointing at before, where you have to watch out for placeholders. So you're going to start, if I want to do synthetic, the fact that I'm dividing by x minus 1, this is fine. I can put a positive 1 the outside of synthetic division. Now if I do 1, negative 1, 1, are those the correct coefficients that go on the top? Hopefully you're screaming to this computer and saying, no, we are missing terms for the x cubed, and we're missing a term for the regular x, so we need to make sure we have placeholders in there. So I have a 1x to the 4th. I have a 0x cubed. I had a negative 1x squared. I have a 0x, and I have a positive 1. So you need to make sure you have those placeholders, or your answer is going to come out to be completely different. You're going to now go through that algorithm. You bring down your column, multiply by the outside, add down your column, multiply by the outside, add down your column, multiply by the outside, multiply by the outside, and then you get your final answer. Okay, so to recap, Last number is your remainder. So I'm going to have some sort of fraction added on to the end of this. The fact that I started with an x to the fourth means my very first term has to start as x cubed. So I have a 1x cubed plus a 1x squared plus a 0x plus a 0. And then I have this fraction, which is a 1 over my divisor, which is x minus 1. If you want to clean this up a little bit, obviously you don't need to show those coefficients of 1. So I have x cubed plus x squared plus 1 over x minus 1. Okay, so you can see synthetic division is probably the method that if you have the opportunity to do, I think would be the easiest one. Obviously, things that you have to watch out for. Don't be, watch out for missing terms, watch out for placeholders. And what I can tell you with these problems, you have to be careful with those careless mistakes. One wrong addition and every single number after that is going to be incorrect, which is going to yield in fully incorrect quotient coefficients. So please be careful of those careless mistakes.